Hi students, welcome to our science class. Today we are going to start new chapter in the text term 2A. This is the textbook and we are going to start the chapter solids, liquids and gases in the page number 73. So just take your textbook. Today we are going to start this chapter and in the last textbook there is one chapter is there. We will discuss it later. Now we are going to deal with solids, liquids and gases. First of all, we can start this chapter with, just observe here, I am just taking one brick. This is one brick here and then I am selecting a beaker filled with water and also a balloon which is filled with air. So these are three different types of substances. Brick is here, water is here and air is filled inside this balloon. Now my question is, do all these things are having same properties or all of they are behaving similar? No, they are not behaving similar. That means they are having different behavior or characteristics. And what we are calling this? For this brick, I am calling this as solid. And for this water, it is liquid. And for this air, I am calling it as gas. That is here, solid is there, liquid is here and gas is here. So, in your textbook, you can see one activity at the introduction part at the page number 73. Here you can see one column. Now, we are going to do that. That is your first activity here. So, the activity is this. They just give some of the materials as the question. And you want to classify this into solid, liquid and gas. These are the substances. Nitrogen, fruit juice, water, paper, oxygen, petrol, sugar, carbon dioxide, and stone. So these are the things that gave in your textbook and there you can see one table like solid, liquid and gas. A table is there you can see and you want to fill this with the examples. So just pause the video and fill that table in your textbook using pencil. I hope you completed your work and what is the answer for that? This nitrogen is what? Gas. Nitrogen. And next is fruit juice. What is this fruit juice? That is liquid. Fruit juice. The next is water. Water is also what? Liquid. Water is the next is paper. So, what is the paper? It is solid. The next is oxygen and oxygen is the inside the gas. It will include here. So, oxygen. And the next is petrol. What is the state of the petrol? Petrol is liquid. Petrol. The next is sugar. And sugar is what? It is solid. And the next is carbon dioxide. Carbon dioxide is also gas. Carbon dioxide. And also we have stone. What is the behavior of stone? That is solid. So this is the answer for our activity. If any mistakes are there, you just want to correct it. So here you can see we have some of the substances are there in the behavior of solid, some of the substances are there in the behavior of liquid, and some of them are in the behavior of gas. Now we want to study what are the common characteristics or properties, or how we can define this. What is this solid, what is this liquid, what is this gas? All the things we are going to discuss in this chapter. Basically we are dealing with the solid, liquid and gases in this chapter, and also we are going to study different examples for this solid, liquid and gas. For that, first of all, we are going to start with the topic matter. How we can define this matter? What is this matter? Anything that we see around us is what? Matter. For example, we can say it as the iron, wood, plastic, gold, paper, oil, oxygen. All the things around us is what? Matter. So, how we can define this term matter? I think you already studied in your 4th standard and all about this matter and all. Still we are going to discuss what is this matter. First you want to remember anything that's surrounding you or anything that is around us is what? Matter. Now we are going to study what is the definition or how we can explain this term matter. The definition is like this. Anything which has mass and occupies space is called matter. So this is how we define matter. For example, this chalk is what? Matter. And it is having mass. Actually, this mass is related to something, the weight. We are always talking about the weight, but actually what it is? Mass. So, mass is something related to weight. Just put it in your mind, such a concept about the weight for the mass. So, for this chalk, it is having mass is there. And also, when I hold this chalk in my hand, that needs some space to hold. So, that's why I call this chalk as matter. That means, anything will be matter that have to be mass needed and also that need space to occupy is what? Matter. This is the definition for matter. Anything which has mass. This mass and occupy space is the two important points coming under the matter. That means it needs mass and also needs space to occupy is what? Matter. And I already said the examples for the matter are iron, wood, plastic, cloth, paper, chalk, board. Like anything is included in matter. So, now my question is, what is this matter made of? For example, you just observe here. We are making buildings. How we are making the buildings? We are making buildings using some sort of bricks or stones like that. So here I am just making a building using some brick. are making buildings or something, it has small blocks we are joining together. Here we used it as brick. And another example, we are making a hill made of sand. This is one hill made of sand. Hill made of sand. So, what is the smaller particle here? What is it? What is this hill made of? This hill made of sand particles or small sand powder. We can say it as sand particle. Sand particle. And what about the building here? We made this building using the joining the small units of brick. So, in the similar way, what is the small thing that combines to make a matter? That is our question. It is nothing but the tiny molecules. It is molecules. So we can say the matter is made of tiny particles called molecule. Tiny particles called molecule. So we can say matter is made up of tiny particles called molecule. And here you can see chalk piece is here. And within this chalk have the molecules of chalk. When we are talking about this board is having the molecules of board. And in my hand I have paper. And for this paper it is having the molecules of paper. That means for each and every substance it is having different types of molecules, but we can say all of these are made of small molecules. And is it possible to see these molecules with our naked eyes? No, we cannot see these molecules with our naked eyes, and we can see these molecules using microscope. We can see these molecules using microscope. And also within this molecule there is also having tiny particles called atoms and all. You will study these all things later. Now you just focus in this molecule. So now we are going to the states of matter. States of matter. Actually, the state means the type of matter itself. That means we are going to classify this matter into three. In your current knowledge, we are going to classify this into three. Actually, the state of matter is not only included in these three states, also having more than 5 states, and now we are only thinking about these three, and that is the solid, liquid, and gas. So the state of matter means the type of matter itself, and actually that is what the solid, liquid and gas. That means the 3 types of matter or 3 states of matter. Generally we are not talking about that the types of matter. We are saying it as states of matter or state of matter. So that is solid is here, liquid is here and gas is there. Now we are going to study each type in detail. And actually what is the difference between this solid, liquid and gas? How we classified this? We classified this by considering the molecular arrangement. Molecular arrangement. That means we already said that all matter is made of tiny particles called molecules. Now we classified this into 3 by considering the arrangement of molecules. That means for the solid it is having a particular molecular arrangement, and for the liquid it is having particular molecular arrangement, and for the gas it is another type of molecular arrangement. We will study this later. And the next thing is this, between the molecules there is having some sort of force of attraction is there. That means we said that this matter contains molecules. Suppose these are some of the molecules. This is the molecule A, this is the molecule B, and this is the molecule C. We are saying that within the molecules they are having certain attractive forces there. That means this A is attracting this B. A is attracting B, and also this B is attracting this A, and also this A is attracting this C, and this C is attracting this A, and this C is attracting this B, and this B is attracting the C. That means this is only some sample of the molecules. That means all the molecules are attracting each other. All the molecules are attracting each other, and we call that as intermolecular force of attraction. Intermolecular force of attraction. That means this is nothing but the attraction within the molecules. That is the only meaning of this. We said that within the matter we have number of molecules are there present, and these molecules are having some attractive force there, and that is called what? Intermolecular force of attraction, or simply we can say intermolecular attraction, or the force of attraction is there between these type of molecules. All type of molecules have certain type of attraction. Now the thing is that when the distance between the molecules are getting increased, the attraction will be get decreased. That is the next point. I will explain you what it is. That is, we are considering some of the molecules. Two molecules are here very near. Two molecules are there moderately separated, and two molecules are very far apart. That means here the distance is very less, or we can say there is having no distance. Here the distance between this is A and B. That means we are all drawing the molecules. This is the molecule A and this is the molecule B. This is the molecule A and this is the molecule B. So here the distance is less. So we can say the attractive force is maximum. Attractive force is maximum. And here you can see some distance is there between this A and B. Still they have attraction to A and attraction to B. And so we can say attractive force is moderately. Oh, they have attraction but it is less than this A and B. So we can say attractive force is moderate. Moderate means average attraction. Or we can say that is less than this first case. This is case A, or case 1, case 2, and this is case 3. And in the case 3, you can see that this distance is too much. Still, this A attracts B and this B attracts A, but the attraction is very weak. So we can say this is weak attraction. So we can conclude this topic or this session as, when the distance between the molecules are getting increased, the attractive force is getting decreased. When the distance between the molecules are getting increased, the attractive force is getting decreased. Very simple. So, by considering the arrangement of the molecules, we are classifying the matter into 3, and that is what? Solid, liquid and gas. Now we are going to study in detail. detail about the solid, liquid and gas. we want to study in detail about the solid, liquid and gas. First point is that the difference between the molecular arrangement. I already said that. Now I am going to show you what is the difference with the molecular arrangement for the solid, liquid and gas. That is, solid is here, liquid is here, and also gas is here. Now we are going to compare the molecular arrangement of solid, liquid and gas. I am selecting one brick piece or some sort of cube. And here I am selecting a beaker which is filled with water. And here I am just selecting one balloon and which is filled with hydrogen or anything gas. So, or carbon dioxide, any type of gas is there. This is what solid, and we are just selecting brick or anything. Now, we are going to study the molecular arrangement within this solid. When we observe this using one microscope, you can see that the particles are arranged in such a manner. This is what the molecular arrangement within the brick. That means they are very closely packed. They are very closely packed means this molecule A is here, B is here, C, D, E, F. This all A, B, C, D, E, F are all very near. Or we can say there is no distance is there between this A, B and C and all. So we can say this is closely packed. Now the question is, do the same cases for the liquid? Now we are going to check that. When we observe this using the microscope, you can see that the molecules are there present in the liquid is not at all this much closely packed. They are through the microscope, you can see that there are having some spaces there between the molecules A, B, C, D, like all the particles are closely packed, but they are less closely packed. Less closely packed. About the liquid, we are just selecting water or petrol, anything. Now, we are going to discuss about the gas. When we are observing the gas molecules within the microscope, you can see that they are having large distance within the gaseous molecule. When you compare this here, the distance between the molecules are, there is distance is there, but it is having a limit. But for this gas, it is not at all closely packed. It is not at all closely packed, and we can say loosely packed. Loosely packed. That means the molecules are very loose. They are free to move. So, this is the first point about the solid, liquid and gas. That is the molecular arrangement within the solid, liquid and gas. When we are looking this, you can understand that for the solid, the molecular arrangement or the packing is very closely packed, or the molecules are the tightly bounded. We can say like that, tightly bounded. And when we are thinking about the liquid, the molecules are there and also having attraction is there, but the thing is that they are less closely packed. That means there is having some sort of distance is there between the molecules. That is about the liquid. And when we are thinking about the gas, you can see that the molecules are very free to move. We can say it as loosely packed. They are loosely packed. This is the first point or the first difference between the solid, liquid and gas. Basically, we are considering this molecular arrangement and we classified it into solid, liquid and gas. And also within this area we have another points are also there and we will discuss it in the next class. Now you want to do one thing, read your textbook 3-4 times and also want to complete your notebook, and we will meet in the next class with the further topics. The same topic is the solid, liquid and gas, and you want to do one thing, just collect some examples for the solid, liquid and gas. That means you just complete your notebook. I will give you the note now. So then write that, and after then you just want to make a table solid, liquid and gas. Then write the examples for the solids here. Write the examples for liquids here. And write the examples for the gases here. That is one homework for you. So it's enough for today. We will meet in the next class with the further topics. Thank you.